and welcome back to day 3 at Rapid Plus TCT. I'm Brandon Ribic, the Technology Director at America Makes, and I'm joined with my good friend John from Open Additive. How you been? It's great to see you.
Good. It's good to see you too, Brandon.
Yeah, how have things been at Open Additive?
Things have been great at Open Additive. We've got a lot of business, and this show's, I think, certainly going to help with that, and a lot of interesting and new technology that's getting ready to come online here.
Yeah, for sure. I mean, there's a ton of folks here. There's been a couple things that I've seen. A lot of folks talking about how to understand equivalency. There's a lot of talk around gathering data, materials qualification. I'm pretty sure that relates to a lot of the things you're working on at Open Additive. So, how about some of that? What's going on there?
Yeah, so we've been working on our sensor platform. It's not really just a sensor or just software. It's really a hybrid of both, and we've been working on it for 7 years, trying to solve the equivalency problem and really also handle the data problem. Where if you're taking high-speed data on an additive process, you can fill up terabyte-sized hard drives very quickly.
Yeah.
So we've been working to develop low-cost sensing solutions where we give users access to the data so it can be analyzed live during the process, and you can only save what you need, or you can save analytics that are being streamed live as the build is going. And so instead of transferring 20 million images or 10 terabytes of data, you can come away with a few hundred megabytes of data with the same key information in it. And so some of our exciting developments recently have been, we've released one analytic for one of our high-speed cameras that does this, and we've got another one we're about to release for our tomography sensor. The platform itself is really maturing and gives users the ability to access either the process data, the raw data, or develop their own analytics that can run on the live data stream.
Yeah, and so when you talk about analytics, I'm assuming that means there's some features within the software on the back end that allow you to look at the signals, but then also try to determine what is a significant or out of family behavior within the signal. Are there some features there that allow the user to understand that?
There's an interface where we have a programming guide we can give to people if they want to write their own analytic that tells them how to access the data from whatever sensor they're looking at.
Okay.
And then an example would be we have a high-speed spatter imaging camera that we're processing data live from. We're looking at basically particles coming off the process, the melt pool, and looking at the dynamics of that process. And one of the things our analytic currently does is look for clumps of powder, large clumps of powder that may get welded down to the surface, because those can impact your recoating process and result in lac diffusion. So we actually identify those on that live data stream and save off the size, location, where they originated from, key metadata about them, like that.
It's really interesting you mentioned that. I think we've been doing some work at America Makes recently trying to understand be it discontinuity formation and as folks kind of call it, the effect of defects, right? So this is a tool to really gain a deeper understanding of what's happening in real time in the process. And not only that, I mean, folks want to understand damage tolerance as well as durability. And so we start to look at fatigue behavior for materials. This could be a really important tool to try and understand how the process is affecting product quality.
Right, and that's the idea. And we've been trying to do effective defects projects and experiments and research for years. And initially we had the same problem everyone else does, which is it's hard to collect all that data, and once you collect it, it's hard to mine through all of it. So that's why we really started developing this platform in the first place.
Yeah.
Where we could automate that. So now we can actually go do the work to do those fatigue studies and those correlative studies.
That's great. Another thing I hear about, aside from the amount of data, right? It's how readily we can integrate these solutions into different platforms.
Right.
Are you doing any work there?
Yeah. So the Open Additive machines, we started making those to do the sensor research in the first place, and spun out into its own product line. But the goal from day one was to make our sensing solution a third-party add-on for any OEM we can work with or get our hands on. So we've got sensors installed on 3 different major OEMs and multiple models for each, and we have integration kits for several different machines and are willing to add more. And it's non-invasive. We don't modify the machines when we do it. So in some cases, we've gotten permission from the OEMs to do it without voiding warranties. So that's really the direction we're going with this.
Oh, that sounds like it's a lot of utility there. That's great. Well, hey, it's good to see you, sir. It's been wonderful to catch up a bit, and I hope you enjoy the rest of your time at Rapid.
All right, thanks, Brandon.
Yeah, you're welcome.